Hey, great. Okay, let's see. Everyone settle down. Awesome. Hey, everyone. So super happy to have you here. Did everyone have a good lunch? Is everyone, or are we having a dip? Or are we good? How are we feeling?
Good.
Yeah, we're good? Awesome, awesome. Okay, so my name is Brinke. I'm very excited to be here. It's my first NDC Oslo as well, so I've been really looking forward to be here today. And in this next hour, I want to teach you everything that you need to know about configuration and secret management in .NET. And then you might be thinking, like, why this topic? Like, I've used iConfiguration before. I know how a database connection string works. Why talk about this? So the reason why is because the way that the .NET configuration system works, it's very flexible, it's very powerful, but I've also seen a lot of companies do a lot of different things, a lot of different projects, use it correctly, use it incorrectly, use it like suboptimally or even insecure. And so I want to tell you everything that you need to know about the modern system, the do's, the don'ts, etc. So I think we have quite a couple of Dutchies in the room. Any Dutch people in the room? I think it's quite a couple. I thought more, but whatever. Anyway, I'm from the Netherlands, and in the Netherlands, you might know we have beautiful flowers with tulips. We have stroopwafels. So if you want a Dutch cookie afterwards, come to me. I have stickers here as well, and we're also very known for our bikes. Well, very, very interesting. We also have the Dutch tax administration. And you might be wondering, why would I talk about something as boring as the Dutch tax administration? Well, I'm not going to bore you with this for an hour. It's because it's a part of an important story about secret management and how companies are doing this. So in 2021, December 2021, there was a Dutch white hat hacker, and he was looking around at the GitHub profile from a Dutch tax services employee. And in there, he found credentials to a private GitLab account. So he was like, okay, I'll just clone that and see what happens. Must be nothing bad. And in there, he actually found like a file with tons and tons of passwords and usernames for lots of services from the Dutch tax administration, including a global Azure admin account. So you can guess where this is going. So what he decides to do is, of course, try to log in. Well, he was writing the email at the same time, right? He's a good guy. Let's not blame him. But he immediately goes to the Azure portal, username, password, correct. But Netherlands, right, we're a very good country. We have it secured with MFA, which was also accepted after like 5 seconds of waiting. So within minutes, this guy had global Azure access to one of the development environments. And all because of like incorrect secret management. That is how easy it can get. And luckily, this story had a pretty happy ending. He immediately reported it to the Dutch tax administration. He got a trophy sent home that said, I hacked the Dutch tax administration and I never got a refund. All right? It's crazy. It's really funny. And I'm glad it had a happy ending, but it's also so simple to make this mistake. Because people think, oh, this is just, we don't make these mistakes. Big companies have this under control. They don't, right? Samsung, March 22. And the thousands of secret keys were found in a leaked source code. Because some of their repos were leaked. They were storing their secrets right in plain text in there. Boom, you have a problem. January 24, last year, Mercedes-Benz's source code for their UI, for their dashboards, was actually exposed because there was a GitHub token somewhere. And someone got that token, cloned their repos, and everything got leaked. And who remembers this, right? Can I get a hand up? Who remembers this Rabbit R1, this AI device? Oh, okay. There's not that many people. I thought there'd be more. Okay, so for people that don't know this device, this was like a device that released last year, and what it allows you to do is it's like a little AI assistant, right? You put it on your clothing around here, and it's supposed to kind of replace your phone. So you can just talk to it, and then it will do all of your AI tasks for you. Sounds cool. Under the hood, it was just an Android app, and it was also very, very insecure. So some researchers did some research into it. They looked into what is happening on the device, found API keys that ultimately would allow them to brick all these devices all over the world, just because they had these API keys. It's crazy how this keeps happening. But it also gets a lot worse, right? GitGuardian is a company around Git security and stuff like that, and they produce a report every year around the state of secrets. So in last year, 24 million secrets got committed into GitHub publicly, right? 70%, let's see what this says. 70% of valid secrets detected in public repositories in 2022 remain active today, so 3 years. 4.6% of all public repos contain a secret, 35% of all private repos contain a secret, and 15% of all commit authors have committed a secret before. So before I introduce myself and really get started, let me ask you, have you ever leaked a secret? Can I see some hands up? I thought there'd be less people or kind of hiding in their chair, but you guys seem really proud of this. Like, yes, me, pick me. Well, it is just a really easy mistake to make. It's a rite of passage. Everyone has done this before. And today we're going to learn what you should do, what you shouldn't do, etc. My name is Sander ten Brinke. I'm a senior software engineer and a knowledge officer at Arcadie. We are a Dutch IT consultancy company, based in Zwolle, the city where I'm also from. And there I do a lot with .NET and Azure consulting, and I have also done a lot with app development and cloud, DevOps, front end, lots of different stuff. I'm an MVP, so I love speaking, blogging, doing open source, podcasting. If you want to learn more about me, look me up. Every session that I give, I will probably also repeat this at the end. Every session I give, I always write a blog post. So if you want to share this with colleagues or you want to watch it back or whatever, scan that QR code. You'll get everything that you need to know on your phone or just in text form, basically. For people that want to scan it later, you'll get it. You'll see it later again. So let's talk about the agenda, right? I'm always telling people, hey, let's interrupt. Let's make it a conversation, a dialogue. Just me sending and broadcasting for an hour is going to be difficult. It's also going to be a lot of people, so let's see what we can make happen. Maybe a couple of questions throughout, but otherwise we'll save it to the end or afterwards. Anyway, the basics of configuration is what we're going to cover first. So what does that look like? Why is it important in .NET, etc. Then we're going to forget that because we should really be using the options pattern instead. Furthermore, we're going to talk about dealing with secrets during development, and then we're going to push to production and talk about some on-prem and also Azure services that help us deal with secret management and configuration management in production. Okay, the basics of configuration. Let's first quickly talk about configuration and why it is actually an important thing, to have. Because configuration, I kind of see it as the settings screen of your application, right? Like we have all of our endpoints, our logic, our UI, our whatever, but we also want to tweak things, right? Logging settings, maybe some API keys, feature flags are of course very, very important. And we can tweak these things maybe while restarting or redeploying our application without having to make any source code changes. And it's a given. I think everyone uses this. But imagine a world without configuration management, right? We need to either have everything hard-coded into our code and then have lots of if statements, or we'd probably, just put secrets in our code and every environment gets a new build with new secrets. It's super insecure and very annoying to use. So it's great that .NET has a configuration system. And in the new .NET, so I'm talking since .NET Core, it kind of looks like this, right? The core of the system here is an interface called iConfiguration. And this abstracts all kinds of configuration providers away from you. So there's app-settings.json, is very familiar probably, app-settings.development.json, environment variables, command line arguments, and other sources, right? XML files, ini files, TOML, YAML, and even if you want cloud providers or the ones you create yourself. And this is all abstracted away. So when you're using the configuration system, you do not know what provider is actually giving you that data, which makes it very, very flexible. So what does that look like in code? So at the end of this presentation, we're going to do a couple of demos, but this presentation and the slides are also very code heavy. So we might have some code somewhere that has an interface instance, a class instance of iConfiguration, right? And we have a method, getAPIKey, and this would be configuration.getValue, generic type, well, in this case, string, API key. So you're telling the configuration system, please go through my configuration, find something that's called API key, and return the value to me as a string. You could also use the indexer pattern, right? So you could say just API key. This will also work. It's just that this will always return a string to you. And that's quite good. That's quite great. I feel for other languages like Python, Java, Ruby, Go, etc., it will probably look kind of the same, right? It's just some not at all. Okay, I see the Java person disagreeing. Anyway. Okay, it's not like that, but it is very understandable. I think we can agree on that, right? It's great, awesome. So the one thing that .NET at least does very differently, in my opinion, is that we have support for configuration structure. Right, so we can have different kinds of files like app-settings.json or other providers. And by the way, all providers support structures, some just in different ways. But app-settings.json is the most logical one. So we have things like logging, so log level for different kind of namespaces, allowed hosts, connection strings to your database, and features, right? So these are all like objects with nested values. And we can actually use this in different sections, right? So instead of like talking to the entire configuration system, we can obtain configuration sections and then do the same operations on those, right? So we could say, hey, I want the features section. So we can say configuration.getSection or configuration.getRequiredSection, right? Like write these right here. And this will then return an iConfiguration section, and this provides the same API, right? Like a get value or the indexer and stuff like that. And one little note, getSection will return an empty object when the configuration is not found, whereas getRequiredSection will throw an error, like it will throw an exception. I always tell people, please use the getRequiredSection because your configuration system is very, well, it's not going to change a lot at runtime. Maybe you change some values at runtime, it's really cool, but your structure is not going to change. So getting like an empty object back is, to me, always like almost always invalid behavior if you're just using a normal system. So getRequiredSection is always my default. But you might also not want to have lots of sections and get section by section and section and section. You might just want to get like a value, like a nested value. So now we can say features, colon, and then I say enable new UI, and now we can get like a Boolean out of there as well. Right? So we have iConfiguration, we have configuration sections. Later on, we're going to talk about why you shouldn't really be using this in your classes, but it's important to know. So then how does this work? How do we get an iConfiguration? Well, the way we do this is by creating like a configuration builder or like a configuration manager. We add providers to it. We call builder.build. And at that point, we end up with an iConfiguration root. And this is the same as an iConfiguration, but it also has a list of providers. You're never really using iConfiguration root. It's also not a part of the dependency injection container by default. But now we have that set up. So in code, right, create a new configuration builder, add environment variables, add JSON file, and then build. But then that begs the question, if we have multiple providers, how does it know what provider to use if we have like a duplicate, right? What if shared settings.json and app settings.json and maybe even environment variables all contain a value for a specific key? In that case, the order matters, right? That's kind of how you're going to work with the system. So here you can see that environment variables was added last. And because this was added last, it has the highest priority. So it's first going to take a look in environment variables, then it's going to search in app settings.json, then it's going to search in shared settings.json. Okay. And that then begs the question, right? We get iConfiguration, but who here has actually, okay, so who's here is using iConfiguration somewhere in their project? Like basically almost everyone except the Java developer. No hate, Java is great. It's just, you have to get some interaction in here, right? Great. So who here has used Configuration Builder? Okay, a lot less hands. So how does that work? And that's because .NET creates a lot of default setups for you. So when you're using like host or web application class in the newer versions or just the generic host thingies, it will create a default setup for you. And this default setup looks as follows. Right? We have an app settings.json, which is added as the first one, so it has the lowest priority. And this is where you're probably familiar with this in like ASP.NET Core projects, in worker services, and here you can store some configuration. Then there's the app settings.environment.json. And this environment is quite special. There's going to be an environment variable on your system called .NET environment or ASP.NET Core environment. And this value will be in that environment thing. So it's going to be app settings.development.json by default. The reason that works is because in your projects you have a properties/launch settings.json file. And in there for the current process, it will always set this value to development by default. So that is why you always have an app settings.json and an app settings.development.json. It's really useful because for test environments, we can set this value to test. And then for staging and production, we can set it to like staging and production. And now we can easily override configuration per environment. It's really, really handy. We set some defaults in app settings.json, like feature flags, like the new UI, we enable it on development, but we disable it on production. But there's also user secrets, and we're going to talk more about this later, which is only enabled during development. So this is the way, and this is where you should be storing your secrets, like your API keys, your database connection strings. This is where you should be storing your secrets in during development. There's also environment variables, right? So you can use that as well. I don't really often use that during development, but especially with Docker and Kubernetes and stuff like that in containers, you're often using environment variables to set these things, the configuration. And then there's the command line arguments. So this is like the highest priority. Even if all of these providers have something like a value for key, the command line arguments will always win. So it's like the final, it's the final hurdle, the final thing that it'll check. So this is the default system. And I feel like, who was aware of this system like this? I see a lot of hands, but I don't see as many hands as people that use configuration. And I feel like sometimes when people are confused about where configuration is coming from, how they should store secrets, in what provider, and this is an important one to remember. And we're going to talk more about that later. So that is something that makes secrets, the way that .NET developers store secrets is very flexible all over the place, because I feel like that is something that is basically a little bit misunderstood. So it's time to talk about the options pattern now. And you should basically forget everything I told you except for that last couple slides, because you shouldn't be using iConfiguration and iConfiguration section in your code like this. Let's take a look at something cool. We're looking at some configuration, right? So maybe in our app settings.json, and that's external API settings, right? So we have an API URL, we have an API key, we have a timeout in milliseconds as well. And wouldn't it be cool if we could now create a class and treat this as code, right? So we could create a class with the exact same properties, and now we could maybe just inject that into a class. So the class might not even know about the fact that this is actually coming from a configuration system. We can add methods to it, we can unit test it, we can do really fun things with it, pass it around. So let's do that. Let's make use of that powerful system. Is this readable for people in the back? Yeah, I see a lot of, yeah, thank you so much. Awesome. So we have a class, external API client, right? And this is going to need the external API settings. So we're injecting iConfiguration, and we're then storing that somewhere in a private field. And now we're going to call an external API. So we're going to need some information. So we're going to say configuration, get section, external API settings, get, and then we're going to cast that to a generic type, external API settings. And this will then go through the configuration system, look for like a property with that same class name, look for all those properties in the class in the JSON, map those, and then give you back a class instance. And now we can treat it as code. Maybe you already have an instance of such a class, and you want to reuse it or you want to enrich it. So you can also say .bind and pass in an existing instance and kind of reuse it as well. And now we can do something with these settings. Just, is there anyone here that sees some problems with this approach? Someone that is in distance of me hearing things as well, because it's really far away.
We have to repeat it in all of our classes.
You have to repeat this in all of your classes. I do agree. That's not something I found that I'm going to talk about, but I do think it's something that I might need to add to the slides. So that's a good one. Thank you. All right. So let's move on. The problems that I see here is that this class has access to iConfiguration and thus can access all irrelevant configuration data as well. This class is able to retrieve settings around connection strings to your database, logging setting doesn't need, feature flags that it doesn't need, or whatever. Now, it's not going to be able to change them, but it's still weird that it has access, because what if we change our configuration structure, right? That's the second problem. If our class has knowledge of the configuration structure, because it knows it needs a configuration bit called external API settings, maybe we change it. Maybe we change it to external API options. And then at runtime, this class is going to break. Maybe it's going to break because it used configuration it didn't actually need. That is really weird. We do not want to have like problems at runtime because these things were tightly coupled, and that's incorrect. And then there's also magic strings in your code base, which is also always kind of cause confusion. So these things we want to fix, because the power is that we can have iConfiguration, we can set it into classes and code, treat it as code, but we're now tightly coupling our configuration to our actual code, like to our business logic. And we don't want to be doing that. We're going to throw it away, and we're going to opt into the options pattern. So the options pattern has lots of different features. We're going to talk about a couple of them, right? So there's encapsulation, dependency injection, named options, validation, reload on change, post configuration, and just a whole lot more. So let's talk about options, and you'll see, and I'll explain why this is the preferred approach for using configuration in .NET in basically all cases. So we can use the options pattern in lots of different ways. This is the easiest one. So somewhere in your application startup or in your program.cs, we can say services.configure, and we're going to tell it, hey, configure the external API settings class again, and then you pass in your configuration system. And what it will now do, when you inject options with the generic type somewhere in your class, and you call .value, because it's a lazy system, only when you call .value for the first time will it then go to your configuration system, and I'm like, I'm looking for external API settings. I found it. Let's now grab all of those properties. Let's map them to the class instance and then pass that into this interface and give it to the user. So it's a lazy system, and it's a singleton as well. So the second time that this class gets instantiated, it no longer needs to go through the configuration system because it will already have it cached in memory. And this basically fixes those problems that we talked about before. There's no more access to data that it doesn't need. It has no way to access database connection strings or feature flags or whatever it wants. This might seem tightly coupled to the configuration system because we, in the previous slide, we said configure and passed in the configuration. But you can set up the option system in many different ways. Like we can also create option instances by calling configure and then doing API calls. So we're calling some API somewhere, getting that data back, putting that in the options, and the class will not know better. The class will see, hey, there's data. It does not actually know where it's coming from, so this is now loosely coupled from your configuration system. And of course, we also skipped out on having magic strings as well. So who is using options who's using options already? A lot of hands. That's great to see. It's good to see. So, validation, right? Just in general, right? Let's talk about validation here. Who here builds APIs? Who here thinks that validating input is a bad idea? Who is brave enough? No one. Okay, see? So everyone here agrees. Validating data user input is always a good idea. Who here validates their configuration system? Maybe 5, 6 people. So I want to kind of, I want to plant that little idea in your head. User input is always kind of scary. We want to validate it, SQL injections, etc. But configuration can be just as painful. Imagine a scenario where we are running on the test environment, but someone has set the database connection string to the prod database, and we're currently testing if deleting everything works. At that point, you've deleted your entire production database. Or if you've maybe set some discount to -1 and some really weird things start happening in your code. That is stuff that you also want to validate, and your application should not start up when it's configured incorrectly. And this is very easy to do with the options pattern, right? So there's an API URL, for example, the API key is back, the timeout in milliseconds, and now we can use these things called attributes you might be very familiar with if you've written ASP.NET Core applications before, where we can say the API URL is required, the API key is required, there's a timeout in milliseconds that needs to be between 1 and 100,000, or that's correct, a big number, I'm not sure, can't read. So, and how do you then actually start validating this? It's just 1 or 2 lines of code. Instead of saying .configure, we're now saying add options, and add options will return us an options builder, and this allows us to do a whole lot of powerful things. So for instance, we're now saying bind configuration, and we're just passing in the name of external API settings. So we're now no longer needing to pass in the configuration system as well. It will just do this based on the dependency injection. And now we can call validate data annotations and validate on start. And this will then throw a validation right when your application starts up when your configuration system is incorrect. Now, of course, validating that your test environment is connected to your test database is not something you're going to do with attributes, but you can also call things like validate and pass in your own validation logic as well. And one thing that I want to give to you is that validate on start is extremely important. I already mentioned that the options pattern is actually lazy. So the first time you call .value on it, will it only actually execute the configuration, data grabbing, and also the validation in general. So you could write some code, and then half an hour later, it throws an exception because at that point, only that code path was executed. Always add validate on start, Because only at that point, when the application will start up, it will actually like initialize all of these options and then crash, and your application can't even launch. That is what I always recommend people to do. I think since like .NET 7 or .NET 8, there's actually also a add options with validate on start method just to make this easier. Right. And then you also might want to keep it fresh. I already mentioned like reloading on change or like changing configuration data without restarting your application, which is a very, very cool thing to do. Who here, when they want to change configuration, redeploys their application? Couple of hands, less than I expected, but that's really cool. Who needs to restart their application for configuration changes to get applied? Yeah, that's a lot more hands. Not really a big problem if you're also doing like blue-green stuff where when you start or restart the application, it'll start a new instance, and only after that's done will it actually bring the old one down, so you have 0 downtime. But I don't see that all the time, right? So it would be really cool to be able to change configuration on the fly and then also have that reflected in our application code. No changes required, no redeploy, no restarts. So iOptions will not allow you to do that because it's a singleton and it read once, it cached the initial value. If you want this, you can use iOption snapshot. So this is a scoped service and this will read every scope. The most popular example of a scope is, for example, an HTTP request in ASP.NET Core. So when we inject an iOption snapshot, like at the beginning of the request, I guess for you I should do it like here, I don't know, and we read configuration, during the request, it might change, but even during the entire request, we will always get the exact same value back because it is consistent for that entire scope. It's important. We don't want the database connection string to be something here and something else here during the request, because that's going to cause a lot of bad time. So it's very useful with web requests as well. You do need to keep performance in mind. Because this is going to read your configuration system every request, if you have a provider like in the cloud or something that's just very slow, it's going to slow down every request. So this is something that you do need to keep in mind and might need to monitor a little bit. There's also iOptions monitor. This is a singleton, right? So it's going to read your data in real time. The property here is also called current value instead of value. And this also allows you to say, like, you can also subscribe to changes with an on-change method. So every time the system changes, you get a little notification, so you can do some manual change tracking. This is very useful for background services where the concept of a scope is not really a thing. Like, it's just a thing that runs forever. So these kind of interfaces are very important when you want to really treat your configuration as code and also support reload on change behavior. All right, let's deal with development. How do we prevent the Dutch tax administration mistake? How do we prevent the Mercedes-Benz mistake? How do we prevent the Rabbit R1 mistake and lots of other companies that store their secrets in their repo? Don't. Don't store them in your repo. It's very common to see companies doing this, especially when they have private repositories and it doesn't matter, it's secured, right? It doesn't matter, we can just store them in there. Stuff will leak at some point, right? That's a security thing. It's not if it'll go wrong, it's when will it go wrong. So make sure that you never store your secrets in your repositories. And how do you do that with .NET? There's multiple options, but the supported one, the one that you should use because it's the default one, is user secrets. Don't create an app settings.local.json and add that to your gitignore, and then change your launch settings.json and change that to local. Don't create don't add your app settings.development.json to your gitignore. Don't add it to the launch settings.json and add it to the gitignore. That's so much work for something that's already built in, right? That's the user secrets provider. We talked about it earlier. So what is this? This is another file provider, it's a JSON file, but it's actually stored outside of your repo. So any changes that you make in it are not included in the repo. That also means that whenever you clone the repo, you do not have data in there. So everyone in your team needs to reset the data. We're going to talk about Azure Key Vault later and maybe making that process easier. So how do you use this? Well, you can call .NET user secrets init if you want to do it in the terminal. It's also built into Visual Studio, Writer, Visual Studio Code. And now we can say user secrets set. So we can set the connection string to the data from the database to some data source. We can set the admin password like hunter2. And now we can see something like this will then be created on your disk outside of your repository. And this will be, depending on your OS, it will be stored somewhere else, right? So on Windows, it's stored in app data, Microsoft user secrets, secret ID, which is something that then will be set in your CS proj. It will be like some random GUID, and that is then, that is how it's connected, secrets.json. And then there's also, on Mac and on Linux, it's like in the .microsoft folder, and, then it's stored there. Be aware that they're not actually secret. Microsoft has a thing with naming, and this is another one of them. They're not secret. The user kind of secret because they are just stored in plain text on your disk. Like there's no encryption happening with decryption when your application starts. They're just another file on your disk. If you have something on your computer that's reading those files, when you have bigger problems at that point, but do not consider this a full secure solution if you are working at a company that doesn't want secrets to be stored on a machine. Right? We're going to talk about that later as well. But they are just another provider. But this is then stored outside of the repo, and you can always prevent your secrets from being leaked into your Git commit history. Let's talk about a good setup for local development then. So of course, I should maybe put a warning there, opinions, right? I really like this approach. I'm curious what you think. And maybe we can talk about that later. But this is what I do in lots of companies, and lots of teams like this approach. .NET system, very flexible, very powerful. But the flexibility causes complexity, causes confusion, right? So if I need to know where the database connection string is coming from, and we're using like 6 different configuration providers, good luck. Good luck figuring out where to go, what to do. What if there's like 2 values? Which one is correct? You're going to have to try all of them out. So I like giving a little bit of structure into these files. Right? So in the app settings.json, I have like little placeholders, right? I create like database. Oh, that connection string comes from the Azure Key Vault. The admin password might come from the Azure Key Vault. The welcome text, that is just stored in the app settings.json. I don't mind. So that's just hello world. App settings.development.json. I like to make sure that to tell people, hey, you should use your user secrets here. This is the place to start learning about this. Because if you don't do this, people might still accidentally put the actual password in this file, commit it, and then you have problems again. Now I'm telling people, hey, you want to grab or insert a database connection string? Actually, you're supposed to do it in the user secrets. And we're also overriding the welcome text to hello developer, maybe. We can also do that as well. And then your user secrets, well, that's what I showed you in the last slide, right? Here we can say connection string to the database, admin password hunter2. And when you combine all of this, you've given the developer and your team and yourself a little bit of a handhold. Like, hey, these are the providers that we're using. If you want to know where something comes from, if you want to update something, this is a very nice approach. One thing that I'm kind of thinking about, like over the last few years, is maybe changing this to just like nulls or empty strings and then adding comments instead. Because now, the null empty string requirement, will just succeed because there's actually a string in there. So you could also just do everything in comments. It just doesn't look that nice. I don't know. Something you can think about. But something like this, telling people where it's coming from, is a good idea. I also considered putting it like in the README, but then no one updates that stuff. So then this is just gonna, get out of sync over time, and it'll just get worse. So I think putting this kind of stuff to where developers look makes sense. Right. One more thing I wanted to say here as well. So for like Docker and like Kubernetes world, it's also very common to just do everything in environment variables. In that case, I would still just say from env or something like that. Or maybe if the environment variables are stored in Azure pipelines, maybe from Azure pipelines env or whatever like that. Make it easy for yourself. Because I think we all spend a lot more time looking for like secret and configuration values than we actually think we do. All right. So it's time to push to production, right? We know configuration, we know the option system, we know to use user secrets, and now we need to go to production. Because the user secrets provider does not work in production, we need to look for different approaches. Right. So what are some common approaches? I'm curious, when I explained this, let's do a little raise of hand and see who uses this or has seen this in the wild. So what I see quite often is that developers create like a little placeholder in their app settings.json with like a hashtag, curly brace, like connection string, and then curly brace hashtag, and then they replace this in their CI or CD pipeline. I hope you do it in your CD, because then you don't have to rebuild. And at that point, your secrets or configuration values are stored in Azure pipelines or like as a secret. And then when you deploy, they are actually stored into that file, and that works. Who uses this approach? I see quite a few hands, kind of what I expected as well. So why I do not like this approach is because it goes against this default setup from .NET, where providers add like order and like add priority to each other. So instead of like overriding like a low-level provider like app.settings.json or app.settings.test.json where you want to insert secrets, why not consider like environment variables, right? You could in your deployment start using environment variables instead. So now you can also, do something like this, like during your deployment, is it like Docker or Kubernetes or whatever, and then you can set connection strings underscore underscore database is some value. So this value still needs to come from somewhere, right? And I also like this approach a little bit more, though this is like, it doesn't really matter, but it makes me feel better, I guess. It's because then environment variables to me feel a little bit more secure, maybe, than files. I'm not really sure about that yet, but that feels a little bit nicer because developers often also then just go to the test or production server and then copy that file to their disk, and that kind of just teaches them that that is okay. And I just want to, make it a little bit more hard for developers to just steal secrets, I guess. I don't know. In any case, this works a lot better with what .NET wants you to do, to use another provider or maybe even add your own provider instead of changing lower level ones. But then there's still the problem of where do we store those secret values, right? Now we've changed the way that we set them into our application, but they still need to come from somewhere. You can use Azure Pipelines variables, you can use GitHub Actions, secrets. It's all right, but it can be quite painful to manage those, right? So then there's the cloud. So I'm going to talk mainly about Azure now, but I want you to know that like AWS has their secret manager, Google has their secret manager. You can even use HashiCorp Vault if you want to do this on-premise, like if you are like a no cloud club, that's fine. But this all works. And the cool thing about .NET configuration system is that you can create your own providers, which all of these companies and all of these cloud providers, they have NuGet packages that add a configuration provider for their secret store. Right? So the Azure Key Vault, in this case, stores keys and secrets and certificates for you. And this can then be used as a configuration provider, and it simplifies your deployment so much. No longer in your CI/CD do you need to store them somewhere and then add them to your environment variables. And that's going to always be really annoying to do because you always need to change that stuff. You can just, when your application starts, it will go to the Azure cloud, grab the values, store them in the configuration system, and you're done. It'll just store them in memory, which is, I guess, also a little bit more secure. The Azure Key Vault also integrates with lots of other services like the Azure App Service and stuff. And this is also really useful during development. I talked about the user secrets being kind of secret because they are just still stored unencrypted on your disk. You could also say, well, maybe I don't want to store secrets at all. And then this is a really good approach for local development as well. Because now you can just clone a repo, press run, and then it will just run. Like it will immediately go to the cloud, grab those values, and you don't need to spend any time setting up these secrets locally on your machine, which is always really, really boring. And then there's also Azure App Configuration. Now, depending on how much time we have, I will do a demo for this in a few slides as well. We'll see how much time we have. But this is Azure Service for like configuration as a service. It's like your one-stop shop for managing your configuration just in one place. It has feature management, so you can like change feature flags for like A/B testing. You can change your features or your configuration values in the cloud without having to redeploy your applications. It integrates with the Azure Key Vault, right? So we can create in Azure App Configuration like a API key, and then we can say grab the value from the Key Vault instead. So now your code only needs to have the add Azure App Configuration source, and no longer do we then need to mess around with lots of different providers. Right? We could sacrifice the flexibility of .NET configuration system and just use app configuration. We could also do both. I always like using the Azure App, like the Azure Key Vault, and then or Azure App Configuration, and then still overriding it with the user secrets again, because then I have the final choice. Like the Key Vault provides me the values for like by default talking to test, but if I want to talk to my local database, I put my local connection string in user secrets, and because that is then the final provider I added, that one will then win. It's different approaches you can use here. And it's super simple to get started with this, right? We just add a NuGet package, options, connect to app configuration, and boom. But then we do have a new problem. right? How can we securely connect to these services? It's great that we have a key vault or app configuration or AWS secret store or Google or whatever, but we need to pass in probably some kind of authentication, like a username and a password to talk to these things. If everyone would just be able to access my key vault, I've not really secured anything because now it's just easier for my secrets to get stolen. So what do? Do we put a username and password in our app settings.json? No, because then we're committing them into the repo again, right? We just moved the problem somewhere else. And for Azure, that is where the Azure authentication stuff comes in, the Azure identity libraries, for example, right? So we already saw 2 slides ago the default Azure credential. And there's tons of these available to you, like the managed identity credential, Visual Studio credential, etc. And the default Azure credential is pretty good for local development. Because what it will do is it'll take a look, like if you're using Visual Studio or VS Code, or if you're logged into Azure CLI or Azure PowerShell, it'll look for your Microsoft account credentials and then try to connect to your key vault. And most of the time, or basically always, that'll work because, hey, you're logged in with your Microsoft account, your Microsoft account is allowed to access the key vault, so then you don't even need to store any secrets to connect to the key vault at all. You can give me, or I can give all of you my key vault URL. You can try to connect to it. It won't work because I have not given you permission in the Azure cloud on your account to talk to my key vault. And if there's no secrets to manage, that's just the perfect world, right? But that is for development. So what happens when we're not running in development? Because I hope you guys are not installing like Visual Studio on your production servers, because you shouldn't be doing that. I add it on prod, by the way. It's the fastest deployment strategy. So for production, there's like in the default Azure credentials, there's multiple providers available. There's the environment variables that it'll try first, then there's the workload identity, and then there's the managed identity. Let me tell you first, I do not like using default Azure credential in production because, first of all, it's very slow because it's going to loop through multiple methods. And maybe if you're using managed identity in production and then someone sets the environment variables, it'll use that one because that one is checked first. So then you might get really weird scenarios where suddenly your system stops working because now it's authenticating differently. If you're using managed identity, just create a managed identity credential. It'll be a lot faster and a lot more clear about what you're doing. So let's talk about them. Yeah, I can have a whole session on managed identities and how they work, and they do exist. There's some really good resources online as well. So let's just kind of try to summarize what is happening here. So managed identities allow you to safely communicate with Azure without secrets. And this only works for services that are hosted in Azure, right? So we could have an app service, and that would have a managed identity. And then we can talk, and we can tell the key vault or blob storage, this managed identity, so it's kind of like an Azure system user, is allowed to talk to you. And when your app service, which is then connected to this managed identity, performs a call to the cloud, to the key vault, it will recognize like, hey, I know that guy, and that guy is allowed to talk to me, and now you need to have 0 secrets to communicate between your services. This is, of course, not going to work when you're using something like SendGrid or some other external API like OpenAPI stuff. Of course, you still need the API keys for that, which you can then store in the key vault. But if you're connecting to another Azure service, managed identities are super, super powerful. Here's a concrete example, for the database, right? So normally, you should never show your database connection strings to anyone. There's always going to be some authentication details in there. But here, it's quite okay. Like, I still wouldn't really recommend it. I still store these things in the key vault because what if someone does add a user ID and password to it? But as you can see, there's no user ID and password in there. The only thing that's in there is authentication equals Active Directory default. And this will then, in SQL, like in the Azure SQL driver things, will then again try connecting to all of these different providers. So again, you can't leak secrets when there aren't any secrets to leak. I see that we're doing great on time, at least for me. So let's have a look at a couple of demos. Let me switch to my code here. All right, if I blind you guys, let me know. Is this okay, or should I switch to dark theme? I see a fan of dark theme, but I saw more thumbs up, so we're going to keep it like this. I do agree. Dark theme is better, right? Okay, and also, is this big enough, or should I zoom in a little bit? It's good. Also, from all the way on the right, it's good. And the left, and everyone together. Okay, sorry. I have minutes to waste. So anyway, so what we're looking at here is a little application, an ASP.NET Core application that I've configured with like user secrets and the key vault. And what it allows us to do is there's two endpoints, right? And then we're going to get into the nitty-gritty details. There's two endpoints, /pizzas, where we're going to get a list of pizzas. And then there's an endpoint /connection string. You should always add this to production. It's really good. You should no, don't. So this endpoint will then return to me my database connection string, so I can show you guys what is happening. And what we're doing here is we're saying when the application starts up, if the environment is not development, then I want to add the add Azure Key Vault with this URL that's stored in my configuration system with the default Azure credential. Now, I talked a lot about also using the Key Vault during development. I've basically switched to always doing that, because it just makes my developer experience so much easier. The onboarding in the team is so much better because someone can just clone and play. But if you don't want that, if you don't want to pay a couple extra cents it costs, or if you do not want an internet dependency, this also works. But now the secrets need to be coming from my user secrets. So you can use the CLI for this, like I showed you in the slides. But for example, in Visual Studio, if you right-click on a project, you can click on Manage User Secrets. And then this will, if it's not initialized, initialize it. And then it will load for you your JSON file. And like I said, this provider, and it doesn't want to work, there it is. This provider is not in my repo, right? So it is somewhere in app data. So any changes I make to this file and save, you can see there's no changes in my Git repository. So this is what you should be using by default if you're going to store secrets anywhere. So my app settings.json is telling me the key vault URI is kv, like secret storage.vault.azure.net. My app settings.development.json is telling me, hey, during development, I want you to store that thing in the user secrets instead. And then, yeah, that's basically it. So I can say when my EF core database contact gets initialized, the connection string, in this case, because it's just a single line of code, in creating options for all of this, to me, is not really worth it. It's more about the business logic where I'm using options for. I'm telling it, get me the connection string, give me configuration, give me the connection string to the database, and connect. So here I'm running locally. Let me zoom in a bit further. And I'm going to execute the pizzas endpoint. And this will... What? This is the first time that this demo has not worked. The connection... Oh, wait, no, that makes sense. Because I have... Is this the problem? Yes, right, because I had incorrect stuff in my JSON file. Good. Okay, so here we can see like salami, Hawaii, margarita, discussions on Hawaii being a real pizza. We can take that place after. But for now, you can see it is connecting to the database. It's using the user secrets to talk to a local SQL server. And the connection string is data source equals dot. And it's connecting to a local database. I've already deployed this in the best possible way to the Azure cloud by clicking right-click deploy in Visual Studio. And now we can have a look there as well. Give me a list of pizzas. It uses the same, and this is actually using an Azure SQL database. Give me the connection string. And here again, this is what I showed you in the slide earlier. There's authentication, Active Directory, default, right? So this connection string does not contain any secrets. Still, I store it in the key vault. I still think it's important to store these kind of strings in the key vault, because you could say I'm just going to store it in the app settings.json in production. But if someone accidentally adds a secret to it because they're not really aware of how this stuff works in Azure, then you've immediately leaked the secret again. So storing these things, I still find them secret enough to treat them as such. Right, and I've been locked out of my entire portal. Please, please, don't let me log in. Right. How much time do I still have? 10 minutes. So I'll quickly log in. Let me just quickly do an MFA. Other ways to sign in. Authenticator request. Just click approve. You don't need to check it. Number 53. Yes. Azure portal. Amazing. So here's a little example of how this is set up in Azure. I have in my repo, I have a little PowerShell script with like the AZ shell that deploys all of this, so you can kind of see exactly how it works. But here, when it's all deployed, we have an identity in our app service, and that is a system assigned identity in this case that is enabled. And then we, for example, can configure our resource group, and then we can go to the actual key vault. And we can tell it, well, here's the secret to the database. And we can have like access policies and RBAC, and then tell it, hey, this application, the app service, is allowed to list and get your permissions. So now I have no need to manage any passwords, any usernames whatsoever. It's just done in cloud, in the Azure cloud. And I'm pretty sure that AWS has the same thing, and the Google Cloud probably has their own things as well. I can still quickly show you app configuration. So here I have Azure App Configuration. This is optional. Like I don't always use this. It is quite costly a little bit, and it also depends if you're going to use the features. Like if you don't care about feature flags and like A/B testing and like changing things on reload, you might not need it. I think the Azure Key Vault is basically required for any secure project. This is a nice to have to me. Depends. The consultant answer is it depends, right? So here we have the connection string to the database, which is a key vault reference. And then I have like a hello, which is like a value of like maybe like world. And then in my code, I can connect to this in the program.cs here by saying builder configuration add Azure App Configuration. And we can connect to the app configuration that is stored in the app settings.json, because it's not a secret, it's just a URL. And then we tell, hey, if you want to talk to the key vault, please use this default Azure credential. And then maybe if you want to have Sentinel keys, which in short allow you to have one key, and when that value changes, your entire configuration setup will reload instead of it constantly checking every configuration value. So it's a bit more efficient. And now we can just have this as an extra configuration provider, and this will just work. All right, so here we have app configuration URL, and then it's set to the one in the cloud. And that's basically all there's to it. There's this deployed to Azure script that I mentioned earlier. It's going to create the database. It's going to create SQL Server. It's going to create an app service plan. And here it will create like a managed identity, and it'll tell the key vault, hey, let this managed identity get and list your secrets. And that's all there's to it. Okay, let me swap back. There we go. It's taking a while. Let's have a look. There we go. Okay, let me just quickly go back. I'm sorry for the flashing. There we go. Right, final two slides. Feel free to take your phone out and scan this QR code. It brings you right back to that blog post that I talked about earlier. There's some useful comments from people in the community as well that say like, hey, there's also this configuration key name, and it allows you to be even more flexible. It's really cool. So .NET's configuration system is powerful and very flexible. At its core, you can use iConfiguration with a set of providers to access your configuration. Use the options pattern to decouple your code from your configuration. This also allows you to use advanced features like validation and more. During local development, user secrets should be used to prevent leaking secrets into your code base. Store your secrets in the Azure Key Vault and retrieve them at runtime by using the related iConfiguration provider. Consider using this for local development too, together with Azure App Configuration. And finally, make use of Azure Managed Identities to connect Azure services together without needing any secrets at all. NDC Oslo, it's been so much fun to speak here today. It's kind of been a dream come true to be able to present for you. Before we leave and before we do all the questions and everything, let me just say that if you want a Dutch cookie called a stroopwafel, just come to me. There's lots of stickers that I always bring, so if you're interested in laptop stickers or maybe for your suitcase before you go home tonight, go and get some, and thank you for your time. All right. Any questions? And if it's too much or if you're on the back, just come to the front. I'll be here for like another hour before I have to go home.